Hello, and welcome to our lesson on solving problems with the cosine rule. So in this lesson, we're going to use this formula, which is the cosine rule, to work out an unknown length or an unknown angle in a triangle. So you can see this formula has lowercase a, b, and c, and these refer to the lengths in a triangle. And it has an uppercase A, and this refers to the angle A. So for our triangle here, we're going to work out the length of x. And because we want to work out this length, we're going to use this angle, which is the opposite angle. So I'll call this angle A. And I'm going to label the other two angles B and C. So now you can see that this lowercase a is opposite the angle A. So the length x I'm going to call lowercase a. And we'll label B and C. So now I'm going to substitute our known values into this formula. So we have a squared, which is x squared, is equal to b squared, so this length squared, plus c squared, which is this length, 6 centimeters, minus 2 times b, which we know is 8, times c, which we know is 6, times the cosine or cos of the angle, 122. We can work all of this out on a calculator. So x squared is 151. Now to work out x, I'm going to take the square root of both sides, because then these square and square root will cancel. So I'm left with x is 12.3 centimeters. So this is how you work out a length using the cosine rule. And now we're going to work out the angle y. And to do this, I'm going to draw a diagram again. So to work out this angle, I'm going to relabel the vertices. So this angle is the angle A. So we have A, B, and C. It doesn't really matter how I label these two vertices. So now we know this length is A, this length is C, and this length is B. So we go back to our formula, where we have A squared is equal to B squared plus C squared, minus 2BC cos A. And I'm trying to work out the cosine of A now, which means I need to make this the subject of our equation. So I'm going to move negative 2BC cos A to the left-hand side of our equation. So I'll add it to both sides. And this gives us, so next I'm going to take away the A squared, which means these will cancel. And finally, I'll divide both sides by 2BC, so these will cancel. So now we've got our formula. I'm going to substitute in the known values from this diagram, where B is 12.3, C is 8, and A is 6. So when I work this out on a calculator, I get cos A is equal to 0.911 to three significant figures. So finally, to work out A, I'll take the arc cos of both sides. So these will cancel. So angle A, which we're working out as y, is 24.4 degrees to one decimal place. Okay, let's try another question. So in this question, we're told that a man sets off from W and cycles 6 kilometers on a bearing of 045 degrees to a point X. He then cycles 8 kilometers on a bearing of 322 degrees to a point Y. And we've been asked to work out the distance WY. So when we solve problems with a cosine rule, we're quite often asked to model a bearing problem. So to solve this problem, I'm going to begin with the point W, which we'll put over here. And from W, I'm going to draw a north line. So we're told that he cycles for 6 kilometers on a bearing of 045 degrees. Now bearings always go from north, and they're always 3 digits, and clockwise. So we have clockwise of 45 degrees. And this is 6 kilometers. And at this point, we have X. So from X, I'm going to draw another north line, and then he cycles 8 kilometers on a bearing of 322 degrees. So again, we have our north line. We're going to rotate 322 degrees, which is just past 3/4 of a turn. And then we have 8 kilometers. And I'll label this as 322 degrees. And this is then point Y. So from Y, I'll draw in another north line. And we're being asked to work out the distance WY, which is this distance here. So to model this as a non-right angled triangle, because I've been given these two lengths, and I've been asked to work out this length, I'm going to use this angle. So to work out this angle, we're going to use corresponding angles. We'll continue this line from W to X beyond X, and we can see that this angle is 45 degrees. And we know this is now a straight line, so this is 180. So this angle will be 322, take away the 45 and the 180, which is 97 degrees. So now I'm going to sketch this again as a triangle. So to use our formula, I'm going to label our vertices with this as angle A. This one can be B and C. We'll label the opposite sides as lower cases. So now to use our formula, I'm going to substitute in the known values. And when we work this out on a calculator, we get A squared is equal to 111.7 to 1 decimal place. So we'll take the square root of both sides, and this gives us 10.6 kilometers. So this is the length from W to Y. Okay, let's try one more question. So in this question, we've been given a quadrilateral, and we've been asked to work out W. But the cosine rule works with triangles, so we need to separate this quadrilateral into two triangles. And one way I can do this is by drawing the line B to D. So now to work out this angle, I need to know this length. But this length is the hypotenuse in this right angle triangle. So I can use Pythagoras' theorem to work out the hypotenuse. So we have D to B squared is equal to 24 squared plus B18 squared. So we'll take the square root of both sides, and these will cancel. So D to B will be the square root of 24 squared plus 18 squared. And this gives us 30 centimeters. And I'll mark this on our diagram. So now we know the three lengths around the triangle, we can use these to work out X. So again, I'll resketch the triangle. So this is labeled angle A. So now we need to rearrange this formula again to make cos of A the subject. And we'll substitute in the known values. And this gives us cos of A is 0.238 to three significant figures. So we'll take the arc cos of both sides. And these will cancel. So A is 104 degrees, which is equal to angle X. Okay, thank you very much for watching, and I hope you found that useful. Thanks again, and take care.